everyone, my name is Bree and I'm going to take the next 5 minutes to introduce you to humans. You might think you've already met plenty of humans, but these are a different sort of humans. These humans are part of organic compounds that I believe will be a key part of the solution to 3 of humanity's current global issues: agriculture productivity, atmospheric CO2, and water scarcity in agriculture, also known as drought. I first became interested in this subject as an undergraduate student studying carbon sequestration and solutions to climate change. However, now my main interest in humans is their great potential to alleviate water scarcity in agriculture. So, what are humans? Well, simply put, humans are a specific type of organic material found in the soil. You might be familiar with the term humus. Humus usually refers to organic matter in or on the soil. Humus is formed when things like plant matter, animal matter, and scat end up on the ground and get broken down by decomposers like fungi, insects, and bacteria. But that's not the end. The humus is the food that many soil microorganisms depend on. Healthy soil contains billions of microorganisms that are critical to soil fertility. So the microorganisms consume and excrete organic matter in the soil, and in the process, they break it down and transform it. So some of that humus, therefore, becomes humic substances, thanks to those microorganisms. Now, there are a few different types of humic substances: humic acids, fulvic acids, and humins. I will be discussing humins, specifically because they are the most effective at performing ecosystem services that we're interested in, but all humic acid substances do act similarly in the soil. Now, briefly, I will cover soil structure. So, over time, healthy soil that's undisturbed forms aggregates. These aggregates are clumps that you feel or see in the soil. Ideally, soil will feel crumbly when you dig it. When the right combinations of sand particles, organic material like humans, and then microorganism activity, fungal activity, and bacterial activity, that soil will hold together with pores in amongst aggregates. It is important that soil is loose and has pores so that gases, fungi, plant roots, microbes, and water can move freely through it. Now, humans and other organic matter in the soil are very important for the soil structure and as food for these essential microorganisms, and of course for water retention. So humans have a complex carbon molecular structure, as you can see. The molecular structure has many weak positive and negative charges throughout. So that can attract and hold water molecules physically, actually, and it acts like a sponge. Many essential nutrients for plants are also electrostatic, and therefore those nutrients will also cling to humans, and humans therefore are able to retain water and nutrients in the root zone around plants instead of letting them leach all the way out to the bottom or deep away from the roots. The carbon structure of humans are very stable, and it's hard to break them down. Whereas many organic materials in the soil break down in tens of years, humans remain in the soil for hundreds of years. But humans usually make up a large portion of organic material in the soil. However, agricultural land worked with conventional farming practices doesn't usually have much organic material to begin with, usually 8% or less only. This means that microorganisms are starving, and there's almost no naturally available nutrients. That's how the need for fertilizers comes in. So how do we increase humans in the soil? Well, we have to get more organic matter into the ground for microorganisms to work on. The natural tool is large herds of herbivores like this. And of course, in agriculture, it would be something like cows. So in the case of, the trick is ensuring that those herds move on very quickly from an area, otherwise you risk overgrazing and compacting the soil. Farmers can also use tools like this, machinery, and for good human production and soil water retention, it is important for farming practices that they don't leave fields bare. So maintaining a cover crop all the time when you don't have a product crop, and then of course working it into the ground is an excellent tool. So as you're all aware, we are facing a global conundrum in that agriculture requires a lot of fresh water, but we are facing freshwater shortages and climate extremes at the same time as we need to ensure agricultural productivity to support a growing population. I believe humans are part of the answer. Humans in the soil allow a small amount of water from rain or irrigation to support plant life and plant growth for a long period of time by holding it in the water until the plants need it. The U.S. State Department of Agriculture says that for each 1% increase of organic material in soil, U.S. cropland could store the amount of water that flows over Niagara Falls in 150 years. I advocate that we keep soil biology in mind and human formation as part of our consciousness when we're developing those farming regulations and farming practices, and that we work with this natural system of plant and soil reciprocity, and we will have a much more stable food production system that is better able to withstand drought, requires less water, and is more productive than what we have now. Are there any questions?